going on, Algebra Bros? It's Mr. C here, and in this video I'm going to go ahead and show you how to find the inverse of a rational function along with the domain and range of both the regular function and the inverse. So let's start with finding the inverse of this function. It notes in the problem that it's 1-to-1, so that means that its inverse is a function. And since the function is presented to us algebraically, we'll go ahead and put it through the steps outlined on page 3 of the note packet. Alright, so with that said, step 1 is to rewrite f of x as y. So y equals 4 over x plus 2. That takes us to the second step, where we're going to switch the variables x and y with each other. So x equals 4 over y plus 2. Now we're at the third step, where we're going to solve for y. What you'll want to do is go ahead and multiply both sides by y plus 2. On the left, you'll have quantity y plus 2 being multiplied to x, and on the right, we'll just have 4. What I would do from here is go ahead and distribute the x to clear parentheses. We get xy plus 2x equals 4. And we want to isolate y, so what we'll do then is go ahead and subtract 2x from both sides to get xy equals 4 minus 2x. And then, one step away, we'll go ahead and divide both sides by x. So we have y equals 4 minus 2x all over x. Now, of course, you can simplify this as 4 over x minus 2, but I would prefer it as a single rational expression. We're at the fourth step now, more of a formality. Whenever we switch x and y to find the inverse, the y no longer represents f of x, rather it represents the inverse function. So it's going to be f inverse of x equals 4 minus 2x all over x. And that's the inverse of the original function f of x. So now what we want to do is figure out the domain and range of each function. So let's go back up to the top where we see the original function f of x. Since it's a rational function, we want to be sure we don't have division by 0. And there would be a value of x that creates division by 0, and that's negative 2. So based on the design of this function, we want to throw out one particular value of x, and that would be negative 2. So down here, where it says domain of f of x, let's state this. X cannot equal negative 2. And of course, we could form the interval notation for that, which we'll do later on. But since we know that the domain of the original function excludes negative 2, based on the results of page 2 in the note packet, where it says the domain of f equals the range of f inverse and the range of f equals the domain of f inverse, we actually know something about the inverse function based on the domain of the original function f of x. So based on the original domain, or the domain of the original function, x cannot equal negative 2, this tells us that the range of the inverse function would have to exclude negative 2 as well. But I'm not going to write it as x cannot equal negative 2 because we're dealing with the range. Instead, I'm going to write it as y cannot equal negative 2. Now let's go after the other two items. We can either find the range of the original function, f of x, which would give way to the domain of the inverse function, or vice versa. We could look at the domain of the inverse function to get the range of the original. I actually think it's easier for us to find the domain of the inverse function, which of course would give way to the range of the original function. So over to the left, we have our inverse function. It's 4 minus 2x all over x. And with a function such as this, we want to be sure that x cannot equal 0. So that's the domain of the inverse function. X cannot equal 0. Of course, that gives way to the range of the original function. And we'll state it this way. Y cannot equal 0. Alright, so those are the domain and ranges of both functions. All I'm going to do next is simply whip up the interval notation. To say that x cannot equal negative 2 means the following interval notation. parentheses, negative infinity, comma, negative 2, union, negative 2, comma, infinity. Now, of course, that's what the interval notation is going to look like for the range of the inverse function. Negative infinity, comma, negative 2, parentheses, union, parentheses, negative 2, comma, infinity. And we'll whip up the interval notation for the domain and range, in particular the domain of the inverse function and the range of the original. I'll start with the range of the original. It's going to be negative infinity, comma, 0, union, 0, comma, infinity. And that's exactly what the domain of the inverse function in interval notation will look like. Parentheses, negative infinity, comma, 0, union, parentheses, 0, comma, infinity. All right, and that's how we take care of a problem such as this. As always, if you have any questions for me, feel free to reach out to me. Otherwise, thanks so much for watching. I'll see you next time.